8. So I said, I'm going to use the second rule because I see log on both sides of the equation, right? But there's a problem. I have 2 here in front of my log. We said we don't want that, right? We want it in the form log of whatever is equal to log of whatever, right? We need to get rid of this 2. How do we do that? We know a rule. So I wouldn't write out the rule now, right? But the rule is the rule that says n log of n log of m to the base a is the same as log of m to the power of n to the base a. If you need me to write it out, let me know, right? If you want to write it out, let me know. So I can rewrite this as log of x squared to the base 3. And this is equal to log of log of 3x minus 2 to the base 3. Now I can apply my rule. I could say, according to my rule, n is equal to m, so x squared has to be equal to 3x minus 2. But what I need you to remember, the bases must be the same. So you see 3 and 3 here? Bases must be the same for me to apply this rule, right? So because the bases are the same, that's how I know I can apply this rule. So x squared is equal to 3x minus 2. They want me to solve for x. You should notice that this right here, this is a quadratic. Because if I bring everything to one side, I would get x squared minus 3x plus 2 is equal to 0. Everybody understands how I did that? Yes, no? Yes, no? Okay. Just let me know if you have any questions, right? So I recognize that this is a quadratic. How did I know that this was a quadratic? The minute I see a term with square in it, so let me show you. Remember, we did this already, right? So quadratic form is ax squared plus bx plus c is equal to 0. That's what quadratic form looks like, right? And I was saying, you see the minute I see a term with a square in it, that's most likely going to be a quadratic, right? That's what I was saying. By just looking at that, I can tell that this is going to be a quadratic because of that x squared, that square term in there, right? How do we solve this? We know there are 3 ways of solving quadratics: the formula, factorization, or completing the square. Usually you go for factorization first, but not all quadratic could factorize. So after factorization, if you can't factorize the quadratic, then you move on to the formula. In this case, this quadratic can be factorized. So remember, you don't have to use factorization. If you're comfortable with using the formula, you go ahead. Nobody's stopping you. Completing the square, that's just really long. I don't think anybody would want to do that. But if you want to, you go ahead. So x squared, this would be minus 2x minus x plus 1. Remember, we already went through how to solve by factorization. Remember, you would want to write all of this for the examiner because you'd be given marks for it, right? So this would be x minus 2. I will take out the minus 1 here. X minus 2 is equal to 0. Therefore, my factors are x minus 2 and x minus 1. We know when solving by factorization, you have to put each factor equal to 0 and solve for x. So that's why I would say, okay, my factors are x minus 2 and x minus 1. So to solve for x, I would say x minus 2 is equal to 0. X minus 1 is equal to 0. And you solve for x. X minus 2 is equal to 0, therefore x has to be equal to 2. And if x minus 1 is equal to 0, then x has to be 1. This here, x is equal to 2, x is equal to 1. This whole thing is my answer. So you can't just decide to put, okay, x is equal to 2 and completely forget about this x is equal to 1. And vice versa. You can't say, okay, x is equal to 1 and just forget this x is equal to 2. No. Both of them are the answer. X is equal to 2, x is equal to 1. Everybody good with this? Yes, no?
Yes, miss.
Okay. Well, I have to stop here because I already over the time.